This shape is a rhombus. It's like a parallelogram, but all of the sides are the same length. The rhombus has the property that the diagonals bisect each other. So this is exactly the same length as this, and this is exactly the same length as this, but they also cut at right angles. Now let's suppose that the length of this diagonal is A, and the length of this diagonal is B. We can see that this diagonal is cutting the rhombus into two congruent triangles. Let's just consider the top triangle. This length then would be A, and this length is half of the length of this diagonal, so that's B over 2, or a half B. The area of this triangle would be a half times the base times the height, which gives us 1/4 AB. The area for the whole rhombus then, in terms of the diagonals, would just be twice this, because we've got two of these triangles. So that's 2 times 1/4 AB, and therefore that's a half AB. So with the rhombus we have a choice of formulae. We could have the base and the height the way that we do with a parallelogram, in which case the formula for the area is just the base times the height. But also, if we know the lengths of the two diagonals, we can use this formula. So just as an example, suppose that we know that this was 10 centimeters and the height was 8 centimeters. Then using the base times height formula, we have 10 times 8, which is 80 centimeters squared. Now suppose we had this situation where we knew that this was 15, the length of this diagonal, and the length of this diagonal was 8. Then the area would be a half times 15 times 8. If these are in centimeters, that would give us a half of 8 is 4 times 15 is 60. So 60 centimeters squared.